Hello everyone, welcome to NRH channel. Dear students, today I'll do the revision about the first topic because we are going to write the midterm examination on the 17th October onwards. So see in the number system what concept you have to prepare for the examination. Now there are so many types of the numbers are there already I taught. What are the types of the numbers like integer, whole numbers, rational numbers, irrational number? How to representation of these all numbers on the number line? Now just main things is rational numbers. Those numbers we can write in the form of p by q where p and q are two integers and q is not equal to 0. Such numbers are called as the rational numbers. Then what are the irrational numbers? Opposite of this one, we cannot write in the form of p by q where p and q are two integers and q is not equal to 0. Such numbers are called as the irrational numbers. Then how to representation of these irrational numbers on the number line? Then how to find the next concept, how to find the rational numbers between the given two rational numbers. I taught the two methods. One is the mean method and one is the equivalent fraction method. How to find the rational numbers between the given two rational numbers. Now these concepts you have to prepare. Then one more point you have to remember. A rational number have infinite. Rational numbers, infinite numbers are there between the given two rational numbers. Remember, there are infinite many rational numbers between the given two rational numbers. Now see the exercise number 1.1. How to represent the rational numbers between the given two rational numbers. There are two methods are there I taught you have to see. Then what is the irrational numbers and how to represent the irrational numbers on the number line. See the third main of the page number I displayed on the screen. Now see, this is a representation of the irrational numbers on the number line by making the perpendicular, and you have to take these distances 1 unit. Then by compass you have to represent the irrational numbers on the number line, and the few steps you have to write here. Clear? Then come to the next exercise number 1.2. Now same examples here. Before you have seen the solved examples, now here exercise there. How to represent root 3, root 2, root 5, root 7 on the number line. Clear? Then real numbers and their decimal expansion. See what is the real number, then what are the decimal expansions of the real number. Now see, real number means the combination of rational and irrational numbers are called real numbers. The combination maybe a 1 by 2, 3 by 4, root 3, root 5, 0.1 dash dash. These all are the examples of the real numbers. What are the expansion form of the real numbers? See the few solved examples are there. You have to see the solved examples also in the reader here. Now find the decimal expansion of 10 by 3, 7 by 8, 1 by 7. These are the solved examples. By you have to divide the long division method. You have to see the in the quotient after how many digits it will be a continuous here now. Now this is a representation of the expansion of the real numbers. Now next one is the terminating numbers, non-terminating numbers here now. Now see what is the terminating and non-terminating numbers. A fraction divides, the remainder comes 0 are called as the terminating numbers. If the fraction divides, the remainder never comes the remainder 0, such numbers are called as the non-terminating numbers. Now here you can see the examples of the terminating numbers. 1 by 2 means 1 rupees divided by 2, it means each member they will get the 0.5 or 50 paisa. Now this is a terminating, can read the number 0.5. These are the examples of the terminating numbers. Non-terminating numbers, it means that 1 by 3. See the examples of the non-terminating number. 1 by 3 is equal to 1 rupees divided by 3. If you divide this fraction, means you will get the decimal 0.33333, so on. So uncountable 3 will get here in the decimal form. So this number is called as the example of the non-terminating numbers here. Now next one is non-terminating and a recurring number. Non-terminating and a recurring number. If the fraction divides, the remainder comes never 0 and decimal points are repeating again and again. Such numbers are called as the non-terminating and non-recurring numbers. Non-terminating and recurring numbers. Recurring means repeating here. For example, 1 by 3. It is non-terminating number and recurring also, because 0.33 is a repeating here. So you call the non-terminating and recurring numbers. Now one more number is non-terminating and non-recurring numbers. If the fraction divides, the remainder never comes 0 and even the decimal numbers also not repeating. Such numbers are called as the non-terminating and non-recurring numbers. For example, pi value. Pi value is the non-terminating and the non-recurring numbers. For example, one more example, 0.101, 001, 0001, 00001 and so on. These are the examples of the non-terminating and the non-recurring numbers. Now see, now next concept is very important here, now which is show that 3.14267 is a rational number. In the order, in the words you have to write express 3 point, you have to write in the form of the P by Q. Now see whatever I displayed on the screen, these examples are also very important. See how to represent and how to express the given number, decimal numbers in the form of P by Q here. Clear? Now these are the about the terminating and non-terminating, recurring and non-terminating and non-recurring numbers. Now this is an exercise about the all types of the numbers here. Now next concept is a representation of real numbers on the number line. Now see how to represent the real numbers on the number line, maybe a terminating or non-terminating numbers here. Now by magnification glass you have to utilize the representation of 5.37 bar. 7 bar indicates 7 is repeating here now. Now on the number line up to 5 decimal point, means after decimal point up to 5 decimal point you have to represent on the number line now. Now these examples are very important, so children, so you have to practice such examples now. Correct. In the next class we will see the after exercise number 1.4 what are the example based on the these concept here now. Clear? Now thank you for watching. Have a nice day.